6-4 in Advanced Algebra 2, talking about simplifying radicals of any root, an nth root. The whole front page of this practice sheet has some wonderful information on it, but it's a little confusing to just start with that information. I'd rather almost get started, but you kind of know like what you need to do to solve this equation right here. If that's x cubed equals 64, don't you want to cube root both sides in that situation? Like you get rid of a square with the square root, you get rid of a cube with a cube root, you get rid of a fourth with a fourth root, and you see how they kind of make this picture right here? It's the same old radical that you're used to for like square roots, but they put this little dude right here of whatever root that is. That's called an index. It can also be called the root, like the nth root, the fourth root. If there is nothing there, then it's assumed that there's a 2 there, that you're wanting the second root, the square root, if you will, right? If there's nothing here, that's like a square root. If there is any other number there, that's the cube root of 81, or if I put a 4 there, that's the fourth root of 81. Y'all pretty cool with that idea? This is the radical symbol. The thing underneath the radical is always called a radicand. Talking about square roots, there's a principal square root. If the sign in front of a radical, any kind of root, square root, cube root, whatever, if the sign in front of it is positive, then that's the principal square root, or it could be the principal cube root or anything like that. If there's a negative in front, then they want the opposite of it. So square root of 25 we know is 5, and then we want the opposite of that. And if they put the plus or minus, they want both. The basic thing is understanding the difference between, say, this and this. Do you see this over here is an expression, correct? No equal sign whatsoever. To square root 36, you just get a 6. You want the principal square root of it. People are like, I thought it was plus or minus 6. Isn't it 6 or negative 6? This is that situation. Not in this case, because you didn't solve anything. You simplified that. Do you see how you have an equation over here, though, and you are trying to solve for x? Like you want to know what could x equal? Well, get rid of this square. You'd square root both sides, and then x would equal plus or minus 6. You get 2 possibilities. If you solved an equation, you want to know what are all the possibilities. If you simplified an expression, do what the sign in front tells you. If they had a plus there, you give me a positive answer. If they had a minus there, then you'd give me the minus answer. If they had the plus or minus, then you give me the plus or minus. It's just kind of copy and repeat if it's an expression. Today, we're just simplifying radicals. Pretty darn simple. And we're in the real number system. You should know, though, that an even root, right, be it a square root or a fourth root or a sixth root, if we're in the real number system, you can only have a positive radicand, right, a positive radicand. So which kind of root do they want in number 1, baby? Square root, correct? Notice the instructions. Do not use a calculator. You have that perfect note card in front of you. That's for a little bit of reference, just so you can understand how much you know and how much you don't know about these numbers. These are the type of questions you will see on the non-calculator test. Anything that says do not use a calculator in the instructions, very obvious. So, square root of 81, you better know that one. What's square root of 81? And you see why we don't put plus or minus 9? Because it's just whatever symbol's in front of it. It was an expression, not an equation. We didn't solve anything. We simplified it. Number 2, though, over here, they want a cube root. Okay? Can you take the cube root of a negative number? Cube root of a negative. Can you do that? Let's make it like this. Easier one to understand. Cube root of negative 8. Can you think of 3 numbers in a row that are all the same that multiply together to be a negative 8? Negative 2 times negative 2 times negative 2. What kind of root is this? Even or odd? Odd root. You can take an odd root of whatever you want, right? Odd root of whatever you want. If it's an even root, the number underneath the radical must be positive for you to even be able to do it. So can we do this problem? Yes or no? Yes. Sign, since this is negative, it's going to come out negative. What is the cube root of 343? What cubed equals 343? 7. And these are things we're asking you to kind of know without a calculator. Cool? So it's kind of almost backwards of what you've been practicing. You knew what 7 cubed was. Can you go the other way? What kind of root do we got on 3? Even or odd? Even, and it's a square root in this case. Look at your radicand. Positive or negative? Can you take an even root of a negative radicand? Can't do it. Not in the real number system. We did do it before with imaginary numbers. We're keeping it real this chapter. Keeps it real. Next one. Now we start introducing some friends in this guy. Not only are there numbers underneath there, but there are variables raised to a base. It's pretty simple. First of all, it's an even root, correct? Look at it first. Is it positive underneath there? Yep. And then we got the plus or minus. It's going to come down. Do you know what the square root of 4 is? 2. And here's how this works. Square root of a to the 10th. It's a little thing called power over root. This is a 10th power. Isn't this a second root? Correct? Power over root as a division problem. Power over root. 10 over 2. What's 10 over 2 turn out to be? 5. So it would be a to the 5th. You were looking at 2 things in a row that multiplied together to be a to the 10th. Isn't that a to the 5th times a to the 5th? Doesn't that turn out to be a to the 10th when you multiply it out? Power over root. It's just a simple division problem. Cool? Next guy. Kind of root. Even or odd? Odd. So it doesn't matter what's underneath there. 243. Is that a perfect 5th? Perfect 5th. What is the 5th root of 243? 3. And then p to the 10th. What's the 5th root of that? If you do power over root, the base will stay a p, and what will you get? P to the 2nd. Power of 10, root of 5, just divide them. Cool? Let's give 6 a try. Sign's on the outside, so it's going to be negative. It's an odd root, so who cares what's underneath there? Okay? Then it's no numbers besides a 1 in there. M to the 6th. What's the cube root of m to the 6th? M to the 2nd. Power over root. N to the 3rd. Everyone cozy with that? If you can remember, power over root will be in good shape. Today, real easy day. Next guy. Kind of root. Odd. So nobody cares about the radicand. If he's negative, and it's an odd root, the answer will result in a negative. And what's the cube root of b to the 12th, baby? B to the 4th. Why don't you give 8 and 9 both a try? Pause the video. Try both of them. Pay attention to the root. Don't get so fast that you make a mistake. Even root, right? It's a square root. Square root each guy. 4a to the 5th, b to the 4th. Sound all right with that? Same thing here, square root, radicand is positive, 11x to the 3rd. Sound groovy with those. Now, don't make it any more complicated than it has to be. Kind of root. Even. Square, also, correct? Sometimes it's helpful for people to put the little 2 there. It's up to you, whatever you see. But isn't there an entire group to the 4th power right here? Well, I'm going to simplify the whole thing by saying I don't care what's in there. It's all to the 4th power, and then you'd need to square root it. If you use the concept of power over root first, what's the power over the root turn out to be for an exponent? So whatever's in that parentheses, it just kind of cleans up to be this. 4k to what power now? To the 2nd. That's really 4k to the 2nd. Because you took it times itself 4 times in a row, and then you wanted to know, what's the square root of that, so you just split it into 2 equal pieces. Now, can't we simplify this? What's 4k, quantity squared, turn out to be? 16k squared. Box them up. Nice? But do you see why we couldn't do, like, why we don't square root the 4 and we don't square root the k to the 4th? Because it was a group, a quantity to the 4th power. You with me on that? See how number 11 is not like that. It's not this. It's not the quantity of 169r. It's 169r to the 4th. Go for him. We'll have a plus or minus. The radicand is positive. Square root of 169 is? Square root of r to the 4th is? Boom. Done with him. Nice. Give 12 a shot. So let's see how we did. It's a negative on the outside. Correct? It's an odd root, so the radicand can be negative. It'll be cool. And when you take the cube root of a negative 27, what do you really get? What's the cube root of negative 27? Negative 3. And the cube root of p cubed is what? P. And can that clean up any further? What's a negative 3p? It's a shweepy. It's like it's tired. It's shweepy. Next. What root do we have? Square root. Perfect squares. Top of the line of our perfect note card. Isn't the biggest one that we come across 225? 625. What do you got? 25. Something. There's some numbers in here that just There's some numbers in here that just aren't on our perfect note card. The more perfect squares you can memorize, the easier it'll be. You might even make that thing go up to 20 instead of 15. But negative on the outside, 25. What's the square root of y squared? And the square root of z to the 4th is z squared. Make sure you cross your z's. Those all real simple, fine, and dandy. Whoop-dee-freaking-do. Everything was a perfect whatever the root was. Over here, fraction underneath the old radical. There's many ways to deal with it. You can notice this, though. Aren't we taking a square root of all this stuff? Let's look at all these guys before we get started. 36, he a perfect square? Q to the 34th, is he a perfect square? It's real easy to know if it's a perfect square. Is this number a multiple of that number? Is 34 a multiple of 2? Yep, so that's a perfect square. Is 49 a perfect square? And is that an 8 right there? Is r to the 8th a perfect square? So it's all perfect squares. Just square root the darn thing. What's the square root of 36q to the 34th? 6q to the, no calculator, right? 6q to the 17th, dividing it by 2. Give me a denominator now. 7r to the, because they were all perfect squares in the first place, I didn't bother separating it out, rewriting all this stuff. I looked at it first, said perfect, 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 everything is perfect. Next class period, not the case, right? Not everything under there. We'll have to simplify them. Today's super easy. Next, go. Yeah. 10x y squared z cubed. Yep. Next one. Gives the old students tough time on non-calculator tests. They're like, oh, God, how do we do the decimals without a calculator? Very simple. Change the decimal into a fraction. I pray, back in the elementary school, they told you what the decimal places are called. What's one decimal place called? Tenths. What's 2 called? And this has 3 decimals. What is that really called? So why don't we write it as the cube root of, it's negative, correct? 27 thousandths. That's the same number, correct? And what's so great about this now? Oh dear, cube root, negative 27. Isn't that a perfect cube? 1,000, isn't that a perfect cube? What does this turn out to be? Negative 3/10. Leave it like that. If that can reduce, you'd reduce it. That cannot reduce. Groovy? Now, next one. Let's turn decimal into a fraction. Cool. What decimal place are we at? Hundredths. So it's negative square root of negative 36 over 100. Correct? Give it a shot. Got your answer? Here's the answer. Why? Why is it impossible? It's a negative radicand, correct? And what kind of root is it? Just because 36 is a perfect square and 100 is a perfect square, you got to watch out because it was negative in the first place. You cannot take any even root of a negative number. Next one, square root again, correct? Is it a positive radicand? We're going to get an answer. Change that decimal to a fraction. Where does the p to the 10th stay? Numerator or denominator? Where does it go? So 64 p to the 10th over 100, because that was hundredths, right? That would be the 8 p to the 5th over 10. Is that a great final or not a great final? 8/10 reduces to 4/5. Simple, simple, non-calculator type problems. Yeah? Interesting. What kind of root? Even or odd? Even. What is the radicand underneath there? Will it be a negative number or will it be a positive number? The radicand is going to come out positive. Even though it looks like it's negative, you see how it is a negative 2x as a quantity raised to the 8th power, correct? And if you take anything to even power, won't it come out positive in the first place, right? So we can do this problem. I would first realize that I would like to ignore what's in there and do a little power over root simplification to this. What will it really turn out to be? Negative 2x to what power? To the second power. Power over root, right? If you want to take the 4th root of something raised to the 8th power, it'll turn out just being raised to the second power. 8 divided by 4. Sound good? Now clean it up. That'll turn out to be what? 4x squared. Give 20 a shot. It's a whole group underneath there. Since the whole group is being raised to the 4th and it's being second rooted, right, square rooted, that's really that base of 11y squared to which power? To the second. And that gives you 121y to the, what do you do with these exponents? Multiply them together. Yep. Yep. And see, for the other people that don't understand the tricks and the shortcuts, boy, it would be a real pain in the butt to take 11 to the 4th. Or it would be a pain in the butt to take 5 to the 6th and stuff like that, to try to simplify things before you root them, you know. Realize the tricks are, it's the whole group to the 6th power in the cube root, right? So it's really 5a squared b to what power, my friends? Second power. Now we all know what 5 squared is. 5 squared is 25. A to the 4th, b to the 2nd. Nice. Let's see how well you can do 22. There is a group in the radicand. It's being squared, and we want to do a little power over root. What does a square and a square root do to each other? Takes it to the first power, right? So you get 3x minus 1 to the first, which I'm not going to write, to the first. Grooves? That's very nice for this one. I would hate to expand that out 6 times in a row times itself. Instead, I will take that group and raise it to what power? Second. Here's my rule. Ms. Colwell left it like that on her answer key, which it's correct, you know. If it's a binomial squared, we need to practice more binomial squared shortcuts. So I would like to expand that out. Use what you know of how to do a binomial squared and expand that out. M minus 5 squared. 3 steps. What's step 1? Square the first guy. Middle part's what we have complications with. I don't even know what to say. Maybe you know what to do. What do you say? Twice the product. The product is negative 5m. I want twice that, which is, and then finally, done. 24, last one of the day of these. Last one of the day. Last one of the day. Right now in class, I ask the students to get out their factor checklist. So if you're a video person, maybe you can find that factor checklist before we go any further. What means is that there's 3 terms. So that's definitely a trinomial. First thing to look for, is there GCF in all 3 of those bad boys? Nope. Next thing to look for, what's the A value? Is it 1? Nope. So that leads you to believe that you should frowny face factor. But before you want to go to frowny face factor, there's other things to check. Next thing, is it a difference of squares? Now, difference of squares is 2 terms subtracted. What's the other thing to check for before you do the old frowny face thing? Is it a perfect square trinomial? First guy, is he a perfect square? 36x squared. Passes. Last guy, is he a perfect square? Positive 1. Then there's one more thing. If you square rooted both of these guys, wouldn't you get a 6x and a 1 right there in that situation? And this sign, whatever it is, it comes down in the middle. Is the middle guy twice the product of those square roots? So is that a perfect square trinomial? And it'll factor like this. Square root comes down, square root comes down, sign comes down, to a binomial squared as the square root. That is a perfect square trinomial. And if you had any kind of like reasoning skills, beans is how we were taking groups to a power and rooting them, groups to a power and rooting them, I would really, 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 really think about, I bet that factors into some sort of binomial squared, which means it's a perfect square trinomial. So now what's the square root of 6x minus 1, quantity squared, turned out to be? 6x minus 1. Yep. First guy a perfect square, is the last guy a perfect square, is the middle guy twice the product of the square roots. Yeah. Next. Square root of 62. 62 a perfect square? I would just follow the instructions. Does this have anything to do with non-calculator parts of the instructions? Then won't be on the non-calculator test, right? So it says use a calculator to approximate each value to 3 decimal places. Square root of 62. 3 decimal places. You must put the approximate symbol on it, about 7.87. Then what's the next decimal that you would put? 4 is correct. If you're rounding to 3 decimal places, you look at the 4th decimal place and see if that is 5 or larger, right? This is not 5 or larger, so you keep the 3rd guy the same. If the 4th guy was 5 or larger, you round him up. So about 7.874. Cool? Everybody knows how to type in a square root. It's the cube roots and the 4th roots and the 5th roots that we're a little inexperienced with. Back in your geometry, you should have done some cube rooting in that volume section. If you can think of it like this, the magic phrase with all this root stuff is power over roots. See this guy right here? What power is it raised to underneath there? 1. What root is it? So we're going to raise this to what power? The 1/3 power. Since it's a decimal, don't worry about changing it to a fraction. Isn't it supposed to come out as a decimal anyway, according to the instructions? So just type it in, 0.054 raised to, your graphing calculator doesn't have fractions in it. How do you type fractions in? With a parenthesis to the 1/3 power. So parenthesis 1 divided by 3, just like that. You with me? Then hit equals. Round to 3 decimal places, so about 0.378. Wait a minute, let me look at it again. About 0.378. Correct? So how do you take a fourth root then? If you want a fourth root, what power would you raise up it to? 1/4 power. If you want a fifth root, you raise it to the 1/5 power. Get all these puppies done for me. Pause the video. Here's what you should have got, video people. If you have some problems with those, let me know. I'll show you how to punch. Cool. 2 problems left. It's one of the smartest classes I've ever had. Except we can't read very well. These are the easiest problems in the world. Let's just pick one at a time here. Let's read 31, and I want to see if you can do it without my help. All right? Read 31. Pause the video, give it a shot. Substitute your numbers in and stop and check with me. You don't have to do any of that stuff of the defining of arrows because they did that for you. See this R? They told you in words what it stands for. Can you figure out what R stands for? What's R stand for? It's like the speed in miles per hour. R is speed. Cool? And since I don't have like a highlighter or anything handy, I just underline that. Then they give me this L. What's L? I'm going to do a different kind of marking. Say like L is length, you know, like a squiggly underline or something. It just so happened that the words were directly in front of the variable. Sometimes they're not, you know. It's like that's why I underline the variable, underline a word. That's important. Then they tell you what to do. Estimate to the nearest tenth of a mile per hour the speed of a car that leaves a skid mark 300 feet long. They give me this number of 300. What does 300 represent? It's probably either going to be a speed. Thanks. Correct? What is 300? Long. 300 feet long, correct? Isn't 300 a length? Take the formula that they gave you and substitute in everything that you have. R, do we know R? Speed. Did they tell it to us? Nope. 2 times the square root of 5. L, do we know L? 300. That's it. So simple, right? So simple. Straight substitution. Now, punch that in the calculator. I'll do a little bit of cleaning up. R equals 2 square roots of 1,500. All right, take 5 times 300. And then you just punch it in, and then answer the question how they told you to answer the question. R is about 77 point. And then what would be the label you would put on that thing? Just that simple. Smart group, like I said, you know. Don't make it any harder than it has to be. One more problem. You can't get any simpler, especially if you was to grab like a highlighter or something. I mean, look at the phrases. D stood for the distance to the horizon. H was about orbiting H miles above Earth. Look at how I like totally highlighted the exact same phrase again. Instead, where there was an H, there was a 150. Orbiting 150 miles above Earth, orbiting H miles above Earth, same thing. They ask you to find D, so you substitute it in like this. I would just clean up what's inside the radical first. I would type in 8,000 times 150 plus 150 squared. Clean that up first and get that number, then put them back underneath my radical right there. So 3 2s. How many zeros do we have? 2. And put some commas back in there, but realize it has to get square rooted, correct? And then I will square root that previous answer. So second square root the previous answer. That's that ANS button down here. And then they do not tell me how to round, I don't think. So I'll round it to the nearest whatever makes sense. Like, this is what label? Is that what you put on this? Miles. So, I don't know. Honestly, I think to the nearest whole number. About 1,106 miles. I wouldn't mark you wrong if you rounded it to the nearest tenth. It didn't tell you. But it's just like, pretty close, you know, pretty close.